In this video, we are going to talk about what to do if there are repeated linear factors. So the previous video, if you watched part 1, had to do with this 1 over x times x minus 1 dx. And if you think about it, the denominator has two linear factors. You have x, the x term, and then you have the x minus 1 term. If you notice in this example, there are actually going to be two of the same linear factors because this x squared is an x times an x, and then you have an x plus 1. So since two of the factors are the same, you're actually going to do something a little bit differently when you're trying to do your decomposition. So what we're going to do in this example is we're going to have 1 over x squared times x plus 1 equals a over x, which is your first term, plus b over x squared. That's the term that's repeated, so that's why it's x squared, because there are two x's, plus c over x plus 1. So unfortunately, guys, I'm not going to prove why this is in this video, but I want you to at least know how to do it. So what you're going to do is you're going to put a over x, and then you're going to do plus b over x squared. So if your repeated term instead was, let's say you had x times x plus 1 squared, let's say this was a different problem, and this was your denominator only, you would do a over x plus b over x plus 1 plus c over x plus 1 squared. So just keep that in mind. This is just here. I should probably put this in a different color. You can just ignore this. This is just a theoretical what if answer. Okay, going back to where we were. So from here, we're going to do exactly the same thing we did as before. So in order to get this first term to have the common denominator, we're going to have to multiply it by an x and then an x plus 1. This is going to be over the common denominator now, plus b times x plus 1 over x squared times x plus 1 plus c times x squared over x squared times x plus 1. Going on from there, I'm going to go ahead and simplify the numerator, and we're going to have a x squared plus ax plus bx plus b plus cx squared all over x squared times x plus 1. And on the left hand side, just to remind you, we're going to have 1 over x squared times x plus 1. Since we have the same denominators, we can set the numerators equal to each other. And I'm going to go ahead and combine like terms. So I have an a plus c times x squared plus a plus b times x plus, so that takes care of that, and that, so I'm left with a b, plus b equals 1. So if you remember, since there are no x squared terms, that tells us that a plus c equals 0. There are no x terms, and by that I'm referring to the left-hand side. So since there are no x terms on the left-hand side, we know that a plus b equals 0. And since the constant, which is b, on the right-hand side and 1 on the left-hand side, we're going to know that b equals 1. So going from there, let's go ahead and plug this b equals 1 into our middle equation. A plus 1 equals 0, a equals minus 1. Going over to our first equation, we're going to have minus 1 plus c equals 0, c equals 1. So now we have a equals negative 1, b equals 1, and c equals 1. Now we are going to go ahead and plug that into this part up here. So I'm actually going to zoom out a little. Maybe not. And so I'll go ahead and rewrite this so I can see. So we had a equals minus 1, b equals 1, and c equals 1. Okay, so scrolling up. Okay, now I'm going to plug those in. So I always like to put my negative ones at the end, so I'm just going to rearrange these a little bit. I'll start with the c term. Let's just go with that. So I'll have 1 over x plus 1 over x squared oops, sorry, that should be a minus. Let me fix that. Okay, minus 1 over x. So now, since we were originally taking the integral, now we're going to go ahead and do the integral of 1 over x plus 1 dx plus the integral of 1 over x squared dx minus the integral of 1 over x dx. So what we're going to notice here is that this first one, I don't remember from the first video. If not, please just go back and watch it. But you're basically just going to do a u substitution. So the integral of this is going to give you the natural log of x plus 1 plus c, but I'm not going to write that yet. And then the integral of 1 over x squared, if you remember, 1 over x squared is equal to x to the negative 2. The integral of that is going to be negative x to the negative 1, because you do, well, I'm sure you guys know that. And so then from here, we're going to have a minus, and then the integral of 1 over x is just going to be the natural log of x. So from here, we can combine our natural logs. Since they're subtracted, it's going to become a quotient. So now what we have is, I'm just going to go from here. So negative 1 over x plus the natural log of x plus 1 over x. And I actually should have written that in the other order. Sorry, that's why I paused. So writing that in the other order, I will get the natural log of x plus 1 over x minus 1 over x, and then I'm not going to forget my constant c. And that is our answer. I hope that helps. I am also a math tutor, so if you have any additional questions, feel free to set up a Skype session with me. Thanks for watching, guys. See you later.